Hello, hi. I'm back, part two. I worked out in MS Excel some plots, and during my graduate chemical engineering days, I used Bailey and Ollis, fundamentals of biochemical engineering. But since then, during I have a full course in biochemistry, which is equal to two courses. So this I find it easier to understand, I guess, and plus I don't own a copy of Bailey and Ollis. That's basically the reason. So I have studied this. I have worked on my MEng and MASC thesis. I've done the required calculations of Michaelis-Menten parameters. It's all on my LinkedIn webpage, and this is. That's what I did. So I plotted the secret to this is all my calculations. So all my calculations, I took roughly a gram of teaspoon of water solution, salt solution. So I'm assuming that but amino acids are heavier. So this is just a rough estimate for my point at zero, or I should have taken a point, right? But nobody takes a point at zero, because it's all good. So I had in S1 zero point 0.5 plus zero point 0.5 plus zero point 0.5 glutamine, arginine, and lysine. S2 this 1 plus 1 plus 1. So S3 1.5 plus 1.5 plus 1.5. So I had only 3 points for my S3 concentration, and I ran out of lysine, so I have only 3 points for my S3. But it turns out that that's the optimal substrate concentration to take. So the trick to do this is subtracting your points, 0 point from the collected data. Neat, isn't it? So you're all going to ace. You don't need to thank me. All right, give a donation to one of my charities. So this is all there. It's all basic. It's all what you study, what your professors are teaching you, and if you want to, you can cross check V naught equals V max S and Km plus S. So the last plot, what I got, the last plot with my slopes, dp by d versus dt is a time versus product. The slope is v naught, velocity of reaction. So the three velocities of reaction are here, and a little closer. And so this was a plot, an inverted hyperbola, where I plotted the substrate concentrations times zero and the velocity of reaction. So, but that's a Lindweaver-Burke plot. Why am I getting a Lindweaver message from heaven? You do the Lindweaver-Burke plot, but that works only at certain times. That's all textual material. You should look up. I need to, kind of really look into it with different data. This is the best I've done, as but I have forgotten my MEng and MAC worked out solutions. That's all on my LinkedIn webpage. So so a hyperbola goes through the third point, as you can see, and it plateaus off, and a hyperbola V max is 0.3. So this would be grams per mil. Velocity of V max, and Km is 3.5 grams per mil. So it's a little less, I'm thinking, Vmax, but that's the data. That's the data. So Vmax is velocity of, so per minute, think, you cannot make more than point Km is velocity of reaction. Km is, let me see what the units are, millimoles. I think just millimoles, right? Now I remember. Just millimoles. So here I've taken grams. So velocity is, of course, per time, per unit time, right? Because dp by dt is equal to v naught. So 0.3 grams per minute. So that's the Vmax. So km is grams. So 3.5 grams is the Michaelis-Menten. No, km is 3.5. So here. So these are all inches. I couldn't find my centimeter ruler. So 3.5 grams. And Vmax is 0.3 grams per minute. So so that's the product versus product velocity of reaction. So that concludes my study, and I hope you have a good time for doing the same thing on your own, just for practice. Or professors could ask you more questions and plug in all my numbers and calculate V naught and V max. And so just for fun, Vmax 0.3, substrate concentration was 7.3. So Km is so just so V naught is equal to Vmax 0.3 multiplied by S 7. Km is 3.5 plus 7. So 0.37, 2.1 by, so we know 3.5 plus 7, 10.5. So 2.1 by, let me see, by 10.5. Close this. 2.1 by 10.5. I'm going to get a 1.2. 0.2 is V naught, which is correct, which is close to what I got. 0.2 is V naught. So my so V naught V max is 0.3. So 0.2 is V naught with 7. So so what was my so my V naught, experimental V naught, was 0.283347. So but according to the Michaelis-Menten calculations, it's 0.2 with the same set of data, Vmax and so that's a little different, and or a lot different actually. And so you can have fun doing the rest of it. All right, signing out, Gayatri P. Sitaram. Thank you.